So welcome student. So this is the fifth class of the electrochemistry. So in this class we will read equilibrium constant from Nernst equation. Next we will read electrochemical cell and Gibbs free energy. Okay. So first you see equilibrium constant from Nernst equation. So we have read like this. Zinc electrode behaves like negative anode, copper electrode behaves like cathode. Okay, and we know when the reaction start, zinc metal loses its mass, and from the solution Cu2 plus deposited over the copper. So this is Cu2 plus, it deposited over the copper, and here Zn2 plus goes to the solution. Okay, so like this, when the reaction will take place, left side zinc metal loses its mass, and right side copper metal gains its mass, and the voltmeter reading will be 1.10 volt when the reaction is on process. And definitely a stage will come either in the left hand side zinc or in the right hand side copper 2 plus. Out of this any one will completely finish. Okay, that means when either Zn or Cu2 plus, if any one will finish, means its concentration now does not change. So this is called a condition of equilibrium. And when this is a condition of equilibrium, and when the equilibrium condition will come, this cell potential become what? Zero, because reaction now stops. Okay, so this is called your condition of equilibrium in the Nernst equation format. So we know E cell equals to, that is E naught cell minus 0.059 by, for this part 2, that is log Zn2 plus divided by what? Cu2 plus concentration. Or for general reaction we have read, for general reaction E cell equals to E naught cell minus 0.059 by n log Qc. Okay, now when equilibrium condition will come, so this reading will be 0. That means this value become what? This value become 0. That means at equilibrium, E cell equals to what? 0, and Qc equals to Kc. In class 11 equilibrium chapter we have read this. So if we substitute this value here, so what we will get? That means this value is 0 now. So 0, and in place of Qc, what will we write? Kc. So 0 equals to E naught cell minus 0.059 by n log Kc. Okay, so if you will take from one side, so E cell equals to dash. E cell equals to, so 0 equals to this, take E cell, means minus will cancel. So E naught cell equals to 0.059 by n log Kc. Okay, if question will Kc will come, so we can write log Kc equals to dash, definitely E naught cell into n divided by 0.059, and Kc equals to dash antilog of this term. Clearly formula. So remember, so at equilibrium E cell become 0, E naught cell value never 0. E cell become 0, cell potential become 0, and Qc equals to Kc. So if you substitute this value, then the equation will come E naught cell equals to 0.059 by n log Kc. Okay, so question will come, if Kc will be given, E naught cell value will ask. If E naught cell value will be given, Kc will ask. Okay, so here I will retain one question. So here you see, here question is given, calculate the Kc for this reaction. Reaction is copper solid 2Ag plus copper 2 plus Ag. Clear? and inert cell equals to given. That means this value given, question is asking find Kc. So how can you solve now? So here direct we put, so 0.46 volt equals to 0.059 by n is 2, okay, into log Kc. Then log Kc equals to 2 into 0.46 divided by 0.059. Yes or no? And then Kc equals to antilog of this term, means 2 into 0.46 divided by 0.059. Okay, so very easy. So in this method we can use the formula. In the formula we will put the data, then we will get the answer. Okay, so this is the meaning equilibrium constant from Nernst equation. Okay, clear now? Then next concept is electrochemical cell and Gibbs free energy. Electrochemical cell and Gibbs free energy. So this is also very important part. You see, in the earlier we have read, when zinc dipped in zinc sulfate, no reaction. Copper dipped in copper sulfate, no reaction. Both side reactions are not possible, means delta G value is positive, non-spontaneous. Yes or no? That's why what we have done, externally less than 1.1 volt is applied so that the reaction takes place. So you see, just to compare with the thermodynamic concept here. So earlier the cell reaction was not possible, but after passing less than 1.1 volt electricity, yes or no, in the opposite direction of a flow of current, then reaction takes place. So you see, if this is a system, according to thermodynamics formula, if this is a system and earlier the system was what? No chemical reaction takes place, means the system is not feasible. But doing some external work, the work is in the form of dash, the work is in the form of passing electric current. That means here we are doing electrical work done. So when we are doing some work done on the system, then its reaction takes place, means delta G value will be positive or negative. Definitely delta G value decreases, negative, because we know in the thermodynamics, when delta G value is negative, then the reaction is spontaneous. Yes or no? So we can say work done on the system equals to decrease in Gibbs free energy value. Work done on the system equals to decrease in Gibbs free energy value. So and here which type of work done? That is electrical work done. Electrical work done equals to decrease in Gibbs free energy. Yes or no? So decrease Gibbs free energy symbol is what? Delta G. So electrical work done formula in physics we have read, that electrical work done equals to NF E cell. NF E cell equals to minus delta G, or delta G equals to minus NF E cell. So you see, in physics and chemistry, in chemistry work done on the system is negative, but in physics work done on the system is positive. Yes or no? So why, you see, why actually it is different in physics and chemistry? Because if we take negative here, work done on the system is negative here, then this negative will be again become cancelled, it is positive. So that's why, due to this reason, in chemistry work done on the system is always we are taking positive. In physics it is negative. So that's why electrical work done on the system equals to decrease in Gibbs free energy. Clear now? Similarly, if you write standard Gibbs free energy, delta G naught equals to minus NF inert cell. Clear? So remember this part. Delta G equals to E cell. That E cell from Nernst equation E cell. But here standard Gibbs free energy equals to minus NF inert cell. That inert cell is inert of cathode minus inert of anode. Clear? So N is the number of electron loss or gain. So when the numerical will come, direct F we know 96,500. E cell value will be given, calculate delta G, or delta G value will be given, calculate E cell. Similarly, delta G naught, E naught cell value will be given, calculate delta G naught, or delta G naught value will be given, calculate what? E naught cell. Okay, clear now? Check. So one numerical will do from the book. Question is given, the standard electrode potential for Daniell cell is given. That means, so question is standard electrode potential for Daniell cell means inert cell is given. Inert cell equals to 1.1 volt given. Daniell cell, galvanic cell, same thing. Calculate the standard Gibbs free energy for the reaction. Question is, calculate the standard Gibbs free energy means delta G naught for the reaction. For the reaction is Zn solid plus Cu2 plus aqueous gives rise to Zn2 plus aqueous plus copper solid. So here you see inert cell value given. This is given. Okay. Question is calculate delta G naught. So direct. So answer is delta G naught equals to minus N. N is how much? 2. 2 into F 96,500 into E naught. E naught is how much? 1.1. So if you multiply this, then it is energy. So energy, its unit will be joule or joule per mole will come. Clear? So in this format, numericals are very easy. Remember always, first you will write the formula. According to the formula, which data given in the question, first you will check. Okay, then you put this value and you will calculate. Okay, so this is the meaning of what your Nernst equation, then equilibrium constant from Nernst equation, and then electrical work done. Understood the meaning? Again I am telling, yes or no? Electrical work done equals to decrease in Gibbs free energy value. And when delta G value will be decreases, always the reaction is possible or spontaneous. So that's why electrical work done here it is positive, and this equals to minus delta G. Delta G equals to minus will be here. Delta G equals to minus NF cell, or delta G naught equals to minus NF E naught cell. So when standard will be given, this question standard formula will use, and when normal EMF will be given, that this E cell formula will use. Clear? So like this, from also book also you will solve some question. Okay.